Hello everyone, this is Rohini Mirgu from Walchand Institute of Technology, Solapur, talking about the measurement of gain of an antenna. Learning outcomes. At the end of the video, you will be able to measure the gain of an antenna using gain comparison method or direct comparison method. So as we are talking about the gain measurement, let us try to understand what is meant by antenna gain. Antenna gain is the ratio of radiation intensity in a given direction to the radiation intensity of the isotropic antenna when both are provided with the equal amount of power. Radiation intensity is the power radiated from the antenna per unit solid angle. Or I can write it mathematically like this. Gain is maximum radiation intensity by the subject or the test antenna to the maximum radiation intensity of the reference antenna. What are the different methods for antenna gain measurement? Basically, there are two standard methods used for measurement of gain of an antenna, such as gain comparison method, which is also called as the direct comparison method. Another one is the absolute gain measure. In that, there are two techniques. One is the two antenna measurement technique and another is the three antenna measurement technique. In this video, I'll be talking about the gain comparison method or the direct comparison method. So this method is commonly used at the high frequencies. The measurement of gain is carried out by comparing the signal strength transmitted or received with the test antenna that with the standard gain antenna. Now, what is the standard gain antenna? The standard gain antenna is the one whose gain is accurately known and which can be used for the measurement of gain of the another antenna. So the most common example of the standard gain antenna is the horn antenna, which works at the frequencies of 300 megahertz to 300 gigahertz. Antennas, one is the secondary antenna is the arbitrary transmitting antenna, and it is not necessary to know its gain. In place of the primary antenna, there are two antennas. One is the test antenna, another is the standard antenna. Both are placed at a considerable distance. The distance between the primary and secondary antenna must satisfy the condition that R should be greater than 2d square by lambda. That means there should be a far field region. The attenuator pad is inserted at the input of the receiver in order that the antenna under test and the standard gain antenna work with the matched load, so that there should not be any loading effect. So the impedance mismatch can be avoided by putting the attenuator pad at the input of the receiver. This is the diagram shown where the setup of for the gain measurement of the antenna by comparison method is shown. Here you can see the primary antenna, which consists of two antennas. One is the standard gain antenna and another antenna is also placed here whose gain may not be known, but here the secondary antenna is the antenna under test, AUT, which is called as AUT. As you can see here also, the attenuator pad is kept. At the receiving end, there is also a detector and an indicator, and at the transmitting end, there is of course the signal has been provided, a signal source through a variable attenuator. there is a detector as well as a power bridge. The standard gain antenna is the one with the known gain. The standard antenna and the test antenna together forms the arrangement of the primary antenna. So this is the standard antenna and the test antenna together forms the primary antenna. While the secondary antenna is the antenna or the transmitting antenna whose gain we want to measure. And the distance between the primary and secondary is kept to greater than 2d square by lambda. As standard and the test antenna are acting as the unit, there should be appropriate matching of the load and the attenuator pad is placed so that there will be a load matching. It should be noted that the whole measurement, there must not be any fluctuations in as far as the frequency and the power radiated from the primary antenna is concerned. So to ensure this, the power level indicating device or the power bridge is used at the transmitter. So this power bridge is used to indicate that there should not be any fluctuations, to ensure that there should not be any fluctuations. So the method or the procedure is like this. In the first step, initially a standard antenna with the gain is connected to the receiver. This is the standard antenna which is connected to the receiver through the switch S, and it is directed towards the direction of the maximum signal intensity of the transmitting antenna towards the secondary antenna. While properly applied input to the secondary antenna, the receiver reading on the receiver is noted. So the reading on the receiver is noted. Along with this, the reading of the attenuator dial pad is also noted. Let us assume that the attenuator dial pad reading is W1 and the power bridge reading is P1. In the step 2, the switch is now moved to the standard gain antenna SGA. With the help of the switch, and we have made the connection to the standard gain antenna. The attenuator dial is now adjusted again to get the same recording as that of the previous one. And it was in this case, as we have adjusted this attenuator, in this case, if we get the dials reading as W2 and the power bridge reading as the power reading as the P2. So if my reading is now P2 and W2, now I'll take the note these readings of W2 as well as P2. Now on the basis of this, if P1 is equal to P2, the gain of the test antenna will be GP, which is W2 upon W1. The condition is P1 equal to P2. In that case, power gain is W2 by W1, where W is the radiation intensity, or if the power gain is in dB, it is W2 dB minus W1 dB. And in case if P1 is not equal to P2, then the actual power gain and of the test antenna will be the product of GP into P1 by P2. What is GP? GP is W2 by W1. So I can say that the gain can be given as GP into P. GP is the ratio of the radiation intensity, which is W2 by W1, and P is the power ratio, P1 by P2. So in decibels, if I want to find, I can say GP dB plus P dB, or if I put GP as W2 by W1, in decibels it goes to be subtraction. So it W2 dB minus W1 dB plus power in decibels. There can be errors in the gain comparison method due to the polarization mismatch, impedance mismatch, and there can be the errors due to transmission losses. So this is the video about the gain measurement, and these are the references used for preparing this video.